Welcome back to Swell Academy. Here's a video of how you can eliminate fractions in equations, fractions, as well as decimals. Decimal is a fraction is a decimal, right? In a sense. We'll take a look at a few different examples. First one we're going to look at is some decimals, and the key piece here is knowing that past a decimal point you have tens and you have hundredths. So if we see, like in this case, we have numbers in the tenths place, then we will use a multiple of 10 and distribute that throughout this equation. And by doing that, we don't change the value, we don't change the balance of this equation, we're just changing the way it looks a bit, and we're able to solve without using decimals. If you had something in a hundreds place, you would use 100. Let's continue on. 21x plus 6 equals 174. That's basically what multiplying each of these by a 10 will do. We can subtract each side by 6. 21x is equal to 168. I kind of like this. Maybe some would jump to that calculator, but if you look at a 20 times 8 and get it close to 160, and you say, well, okay, well, also 1 times 8, you see with a little mental math there, some tens, hundreds units, we could do a little mental math and say that 21 times 8 would be 68. And here's the way we can avoid basically subtracting, holding the decimal place, and making things easier for us. Here's an example. Here's another good example here. And basically what we're looking at is this idea that you have denominators 5, 2, and 10. And if we did their multiples, 4, 6, 8, 10, we would see that they have a low common multiple here of 10, which would mean I could use this 10 and eliminate all these denominators here. And the idea is if I'm distributing this, okay, again, by not changing the value, 10 over 5 is 2, so basically I'm multiplying this 3y by 2. And if you see here, 5 times 2, 10, 2 times 5, 10, and 10 times 1, 10. So basically that's going to be a result of it, right? 10 over 2 is 5, so we're going to have 5 times the 3 here, okay? And then 10 over 10 is 1, so we're just going to multiply this by 1 here. Well, let's say this is supposed to be equals. Can't have an equation without an equal sign, and we have the 1 times the 7y. And in doing that, again, we see we've in a sense maybe converted this equation into something a little bit more manageable. We're not, finding all these common denominators, just taking a simple number, distributing that, and getting a nice setup. So we could just easily subtract 6y from both sides and get 15 is equal to y. And if we were going to take that 15 and plug that in to this equation, it would in fact equal that result. If we were going to take the time and go through this would be a good fit if you were to check that work. But I want to focus more on the process than the result here. Here's another good one, quick one. You may see where you're just basically eliminating this one fraction. We've seen that x over 5 is equal to 6, and multiply both sides by 5. That's technically what you're doing when you're getting rid of the fraction, but here we have another term here, so we have to be careful. 5x over 5 really is x, so that's the result there. And then 5 times 1 plus 5 is equal to 2. And then the common mistake is we're going to write this x plus 5 is equal to negative 6, and we're not going to distribute all the way here. And we may run into some mistakes here, and we may lose our sign as well. So make sure you're really doing that 5 times negative 6, and you're distributing all the way through. And we're getting a result that is correct. X equals negative 35. And This one I could check real quick just to show you. Negative 35 over 5 is negative 7. Negative 7 plus 1 is in fact negative 6. So we do have a good result there. And the last one we'll do is basically the reverse of what we've been doing as far as taking the numbers and maybe making them bigger. Here we could take the numbers and essentially make them smaller. So I actually want to show you two different ways of working this. I can take the 100x plus 250 equal 400 and divide it by 10 here, divide it by a number common to all three of these, and I could get 10x plus 25 is equal to 40. Smaller numbers to work with, and the other ones we're making bigger to make it easy to work with. Now we're making them smaller to make it easy to work with. It's just a beautiful thing of math where you can change things without changing them, if that makes sense, to make it work for you. But the way I would do this, actually, and it's weird to this video because this video's we're supposedly supposed to be eliminating decimals, but here I'm going to create one. 100 divided by 100 is 1x plus. Now 250 divided by 100 is 2.5. So here I am telling you to eliminate decimals, and now I'm going to go ahead and add one. But it just looks kind of nice. This little small numbers we're working. Same result, and that's another thing I wanted to use. I can divide by 10 on one side, divide by the 100 on the other example, and I get the same result. But the shortcut is there. I hope this helps. Remember, the more you fail, the more you succeed, so keep working hard.